In this video, I'm going to talk about midpoint of segments. And a midpoint of a segment is a point that divides a segment into two congruent segments. If you want to review the term congruent, what congruent means, I made another video on congruent segments and congruent angles. A link for that video is coming up right now, as well as at the end of this video, so you can check that out. Let's draw on the midpoint of a segment. So let's say we have segment AC, and we know we label a segment AC with the two endpoints and a segment on top. And our midpoint is going to be point B. Now, if we know that B is the midpoint of AC, then that tells us that the two segments that are created, AB, has to be congruent to BC. So we're using our congruent symbol here. So this segment here, AB, is congruent to this segment here, BC. And the way we're going to show that on our figure, we're going to put 1 slash and 1 slash through AB and BC. So if AB has a length of 6 inches, BC is going to have a length of 6 inches as well. This is our geometric relationship. We can set up an algebraic relationship where just our length of AB is equal to our length of BC. And we could use this relationship to set up some equations and find the measures of segments. So we're going to use this relationship to do some problem solving. So let's get into some application problems using the midpoints of segments. So for number 1, we know E is the midpoint of DF. We want to find the value of X. So if E is the midpoint, then we know that DE, two segments that are created, is congruent to EF. So it's our geometric relationship, our algebraic relationship. It's going to be DE is equal to EF. So our segment here, DE, is congruent to or is equal to our segment here, EF. So we can substitute in the expression for DE and EF. So we can set up 5x plus 3 is equal to 33 to solve for x. So let's subtract 3. We're going to get 5x equals 30. Divide by 5. We'll get x equals 6. So now that we know x is 6, let's solve for each segment length. So let's solve for DE. We know that DE is 5x plus 3. So we can take that value of 6, put it in for x. So we'll have DE equals 5 times 6 plus 3. We'll get 30 plus 3, and we'll get 33, which is the same as what we have here. We want to find the total length of DF. Well, we know using the segment addition postulate, we could add up our total length. So we could add up 33 plus 33 and the length of DF. That total segment is going to be 66. All right, let's do one more example. Number 2, E is the midpoint of DF. We want to find the value of X. So we know we've got congruent segments here and here. So DE is going to be congruent to EF. It's our geometric relationship, and DE is going to be equal to EF. It's our algebraic relationship, so we can substitute in 2x minus 3 in for DE, 5x minus 24 in for EF. So we'll have 2x minus 3 equals 5x minus 24. Let's add the 3 to both sides. Just subtract 5x. Get negative 3x equals negative 21. Make sure to bring the sign down with that 21. Divide by negative 3 to get x equals 7. Now let's find the length of each segment. So DE is equal to 2x minus 3. Let's take 7, put it in for x. So DE is equal to 2 times 7 minus 3. So we'll get 14 minus 3, and we'll get DE is equal to 11. We should get the same thing for EF. EF is equal to 5x minus 24. So I'll get 5 times 7 minus 24. I'll get 35 minus 24. And EF is going to be 11 as well. So that checks both of our segments. We're going to be 11 and 11. So our total length here for DF is going to be 22. So this video was on midpoint of segments. I hope this video helped you understand this concept a little bit more. If you like this video, leave a like, comment, and subscribe. And you can check out the link for the video that's coming up right now on congruent segments and angles. This is Nick from First Coast Math Clinic.